why acoustics. In today's lecture, we are going to talk about the types of acoustics, basically categorized into two. One is soundproofing and the second one is room acoustics. We have seen in the first lecture the types of acoustics field. Almost like 13 types of acoustic fields have been categorized as per the American Society of Acoustics. But right now we are concerned about architectural acoustics. That is the acoustics related to rooms, within the room, and how we can control the noise and all that. So from this lecture onwards, we are going to get into more specific about the business that we are into, where we give the acoustic solutions for the inside room. As I mentioned, in today's topic, we are going to talk about the two things, soundproofing and room acoustics. Here, these are the two types. The first type, we call it as soundproofing, or we call it as sound isolation. Now, what is sound isolation? Now, let us assume that we are taking this room to be converted into a studio. Now, for a studio, we need to ensure there is no noise that is coming from outside to inside. And same way, what is happening within this room should not be going out. So basically, we have to isolate, right? We have to isolate this room from the noise that is coming from outside, as well as prevent the noise that is generated here. You should not go out. So that is what we call it as soundproofing. That is, we have to cover with some acoustic material around the walls, and sometimes it is done on the ceiling as well as on the floor depending on the condition. And when that is done, we call it as an acoustic isolation or sound isolation, and we use soundproof materials, right? That is one criteria. Now the second is, we call it as room acoustics. Room acoustics. Now what is room acoustics? Okay, room acoustics is something related to acoustic within the room itself. So it is not dependent on soundproofing. Soundproofing is separate and room acoustics is separate. Now let me give an analogy of what room acoustics is all about. Now let us say you got your keys for your new house, right? You are going along with your family. You open the keys and get into the house, and everybody starts shouting. So immediately what you see, the reaction is you get a lot of echoes, right? Because the house is empty, the floor is bare, you have bare walls, bare ceiling, nothing, no furniture, nothing, right? So it is a empty room. So in an empty room, when you generate a sound, you found there is more echo. Why there is more echo? Now, for example, say there are you and your wife, okay, are in that particular room. When you talk to your wife, so what happens is, one is there is a direct sound. Okay, let me show with an example. Two persons within a room, and you are here and your wife is here, okay, and when you talk, when she is hearing, it's not only the direct sound, there is a lot of reflected sound also that she listens, okay. It gets a lot of reflected sound. So along with the direct sound, there is a lot of reflected sound that comes inside the room. All added together gives the overall perception of what the other person is listening, right? Now, in the case of empty room, what happens? It's becoming too echoey, right? The room becomes too echoey. Now, in which case, sometimes it won't be very clear when number of people increases. Now, when you do the housewarming, right? There are so many people. Assume that still the house is not yet furnished. So, what happens? More number of people, more noise, and you cannot listen to the other person clearly. Now, what happens? Because there are too much of reflection inside the house. Now let me take two typical examples in room acoustics. That is, one is a totally empty room like that, right? And another room is, let us take, it is all furnished, right? Furnished, and you have all the absorbent material. Let us assume that all the four walls we have covered with a absorption material. Okay, just a typical example, right? An absorption material like a foam, right? Foam, like a sponge you call it as. So these are highly absorbent material. Assume that all the four walls are covered with this type of material. Now what happens? Now in this case, when you talk to someone, it will be more of the direct sound that the other person is listening. The reflected sound, normally what happens? It gets absorbed. So most of the time it is only the direct sound that the person is listening. Whereas in this empty room, it is fully reflecting, right? So along with the direct sound, there are multiple reflection all combined together. The level also becomes higher. Whereas here is only the direct sound, the level also is quite low. In room acoustic, we talk about something called as reverberation. Now here we tell that reverberation is high. So reverberation, it is high here and it is very low here. It is high here and it is low here. And one of the parameters that we used for room acoustics is called as reverberation time. We call something like as RT60, which we will give a lecture on it on a separate session. Now in this case, the reverberation time is very high, and in this room the reverberation time is very low. Now which is the ideal? So one is the low, one is very high, right? Both are too extreme and both are not good. Both are not good. So there is some value which is optimum for any type of room. Okay, there are international standard which specify for this particular room, for this particular application, the reverberation time should be this. Okay, now based on that, the room acoustics is designed, right? Now I would like to tell what is in common when people talk about acoustics. Now there is no clear distinction that the people make with regard to sound isolation and room acoustics. And in many of the countries where I visited, when people get the things done from so-called acoustics experts, most of them are like, the carpenters, and so I am not talking anything ill about people who are in this business. It's basically the understanding of acoustics is very bad actually. Unlike many other established industries, acoustics is not really has reached the people, and many people are very ignorant about the concept of acoustics, and that is the purpose of our giving this lectures, which will benefit you all. Now normally when we talk about acoustics, people just tell only about just acoustics. They don't know whether they are doing a sound isolation or whether they are doing a room acoustics, because most of them, they don't take any of the measurements which is related to acoustics installation. Now let us say, for example, it is a studio. They immediately cover the four walls, the ceiling, and they dump some glass wool and other type of material and cover with a perforated board. And this is common in Southeast Asia and many other countries where it is very common to use this type of material, and this has been used for almost last 100 years actually. And this is a very I wouldn't say the earlier concept, because earlier it was done with the proper mathematical things, but it has been down the line, it has been duplicated without knowing the purpose. And in such type of rooms, when we try to see it, doesn't even stick to soundproofing, or nor doesn't stick to room acoustics. And when we take measurement related to room acoustics of RT60s, it doesn't match the values. Okay, when you take a soundproofing, yeah, to an extent it meets a soundproofing, whereas the internal acoustics is totally bad. And I would like to stress upon this particular thing. The common acoustic material which is worldwide used, worldwide still it is being used, and is very disheartening to see such materials still being used as a soundproof material. See something like glass wool, fiberglass, rock wool. So these are already banned in the international market. These are all banned materials. When I say it is banned, these materials are not the right materials when people are handling with it. Even when people take with utmost care, these materials are quite injurious in the sense, for example, glass wool, let us take. Now glass wool, it has a very thin strands of glass in the wool form, and it is very detrimental when it is used. When it is exposed in the air, it affects our eyes, as well as when you inhale it by mistake, it also affects. And these materials are categorized as carcinogenic material. Carcinogenic material, it means that such material, when on a long exposure, will lead to cancerous effects. Okay, it doesn't mean, okay, when it is used people get cancer, not that way. On a long exposure, it is found that it may lead to that type of situation. So these are actually a banned material. Now assume that they're a conventional studio, they stuff this material inside that and they put a perforated board outside that. And then imagine when there is a lot of vibration inside the room, this glass wool, the thin fine strands, escapes out of the small holes and it gets filled inside the room, and which is very detrimental and really will affect the health of the person. So it is very important that people should understand that such materials are very risky to use. Even in many of the installation that we have seen, where we have done new acoustics, when we have to remove the old acoustics, many have used glass wool in abundance, and even rock wool, fiberglass. All these materials are banned material. And if you are interested in reading an article about that, how it is banned and why it is banned, we have a copy of that. You can email us, then we can send you a copy of that. So that is the detrimental effect of all the soundproof material which is at present used in the market. So we at G-Acoustics, we have a different type of material that is used for soundproofing and all that. Now, in soundproofing, it also sometimes becomes important that even the flooring has to be done and also the ceiling. Because when you take a room, soundproofing is like a water tank. Like for example, let us take a water tank. Yeah, if there is a pinhole, is it accepted? No, right? Because even through the pinhole, the water leaks. Same way, when it comes in a room, when we say it's 100% soundproof material, that means even a pinhole is considered a leakage inside the room. That's why for a soundproof room, the door has to be a particular grade. We ensure that the gaps within the door is taken. There are no gaps below the door, and so many things has to be taken care in terms of design as far as soundproofing is concerned. And same way, the room acoustics is very important. It's not just the reverberation time. See, there are so many other technical things that is considered, like the room modes. The mode analysis is done, and we see how the sound behaves within a specific room of a specific size and all that. See, all this becomes important to achieve the right reverberation time. When it is a small room, the reverberation time requirement is little low, and when it is a big place like a cinema theater or an auditorium, there little bit the reverberation time is high. And we will talk in depth about the reverberation time possibly in the following lecture. Hope this gives a clear idea about the two types of acoustics, soundproofing and room acoustics. So for your requirement or for your customer's requirement, when there is an acoustic requirement, please ask these two questions. Do you need soundproofing? Do you need room acoustics? And most of the time, soundproofing may really not required, because the place itself will be quiet enough. And what is important as an acoustics is only the room acoustics. But many places I have seen where only the room acoustics is required, they end up covering the whole walls, ceiling, everything, which is not really required. And moreover, for room acoustics, it is not important that you have to cover the whole wall. See, because to get the right reverberation time, we should have a mix of absorption inside the room, there should be diffusion inside the room, there should be reflection inside the room as a combination. That's how we get the right reverberation time. So to achieve that, there is a combination. So when it comes to acoustic panels required for room acoustics, we don't cover the complete 100% surface area. So the surface area that will be covered maybe for the four walls as well as for the ceiling, maybe it would be between 40% to 60% depending on the type of reverberation time that is required inside the studio. Hope this gives you a better idea of what the acoustic requirement is all about. Thanks for watching this video. If you have any questions related to this lecture or any of my previous lectures on why acoustics, you can email me at ganesh@gacoustics.com, or you can put in the comment below under the YouTube channel of G-Acoustics.